This is video 7.4, D as in dog in trigonometry, vectors, operations, and the dot product. Continuing on, we're talking about the unit vector right now. And remember when we did unit circles, we would have a circle, and it went through the origin. Center point was there, and the hypotenuse or the radius was 1. And then we could find out, length of this and length of this, and we used lots of different trig stuff. Same thing is true with our unit vector. Our unit vector has, as a length here, 1 and 1. So our I, we're going to call that, we're going to call that our X. And our J is going to be our Y value. So J goes up 0 and then it goes up 1. And now let's use this one. J goes up 1, I goes over 1. Alright, so if we want to go over 3 and up 4, we go over 3 I's, because I is 1, and up 4 J's, because J is always up or down 1. So 4 times J would be 4 times 1 would be up 4. So actually, it's just 3I plus 4J would be over 3 up 4. It's the same as 3, 4 here. So the U, the magnitude from here to here is over 3 up 4. And we end up at this point, but we say 3I plus 4J gives me the magnitude right there. So just a new way to confuse you. So form of vectors, top of page 310, just like what I said, only they're using a V instead. And this here, I'm not sure why they put it in parentheses, because that should actually be in the little pointy parentheses there. But let's go on with dot product and the angle between vectors. So we probably have maybe 2 more videos to get through this, but we should be okay. So the dot product. The dot product is basically used to determine the angle between 2 vectors. So if I've got this here, and I've got a vector here, and a vector here, and I'm looking for this angle here between these 2 vectors, I'm going to use the dot product in order to do that. So this is the weird thing. When I am looking for the dot product, so let's say I've got U, and I'm saying that equals A, B, and I've got V, and that is C, D, U dot V. That is not times. If I were going to multiply them, I'd put them together as UV. U dot V, that's how you read it, is equal to A times C plus B times D. No little parentheses, no nothing. So the dot product of 2 vectors is the product of the first components plus the product of the second components. Okay? So let's look at the dot product of, say, 2, 3, and 4, negative 1. Alright, so what we're going to do, we're going to multiply basically the x's and add my y's. And I'm going to get 8 minus 3, which equals 5. Okay, not much to that. If I had 6, 4, dot product or dot, be the same thing. 6 times negative 2, so I've got negative 12 plus positive 12 equals 0. Okay, so if we were to show this in a graph, it would kind of look like 6, 4, that's that point there, negative 2, 3, like that. Okay. And my dot product then would give me 0. So bottom of page 310 gives you the properties of dot products, which are basically the same as the properties in algebra. So I'm not going to spend any time on that. But the dot product of two vectors can be positive 0 or negative. And the angle theta between two vectors, let's call them u and v, is going to be the angle having the two vectors as its sides, and it's going to be an angle somewhere between 0 and 180. It can be 0, it can be 180, and it's going to be somewhere between there. The following theorem relates the dot product to the angle between the vectors. So let's look at that, and then we'll start on a new video to get started. So u dot v is equal to the absolute value times the absolute value of v cosine of theta. So basically, if we're looking for theta, we're just going to divide both sides, and that's going to equal u dot v over absolute value of u, absolute value of v. And a key thing to remember, this is equal to, and we got that from the dot product, middle of page 310, that equals AC plus BD. So really you could replace u dot v with AC plus BD, because that's basically what we're doing there. Alright, so next video we'll do a couple of examples.